it turns out there's actually a faster way to deal with initial split data. There's a function in Tidymodels called last_fit, and if you specify the split, this will automatically train the data on the trained data from the split. And instead of specifying which metric to calculate, so like with the RMSE function that we used before, you can actually use collect_metrics, and it will automatically calculate the metrics on the test data from the split. So you don't have to specify the training data and the testing data. This will automatically do it the correct way for you. So this is how this is going to work. And you'll notice I've added a seed here at the top, set.seed100. And what that does is it makes sure that I get the same answer every time. This is good practice if you're working on an analysis script, because the initial underscore split function is a random process. Every time you run it, it's going to give you a slightly different answer because it's going to split the data slightly differently. And so setting a seed makes sure that you get the same answer every time you run it, which is nice for reproducibility and things like that. Okay, so here's how the code works. First, I split my data using this initial split function. So I've got an object called autoSplit. And then I use, instead of using the fit function, I use last_fit. I still specify my linear model specification. I still specify my formula. Miles per gallon is my y variable. Horsepower is my x variable. And now instead of specifying a data set, I specify the split. And so split is going to be equal to auto_split. And what this will do is it will automatically detect what was supposed to be the training data based on the split, and it will fit my model to that training data. And so I'm going to save this output as lm_fit. And then if I want to collect my testing error, I can pipe this lm_fit object into the collect_metrics function, and it automatically calculates the metrics on the test data. So pretty cool. It's a little bit of shorthand, but gets you to the same spot. Okay, so now what about cross-validation? So in the last class, we talked about how this validation set approach, if you have tons of data, maybe it's okay, but it's not totally ideal because you're basically just splitting the data in half. And so in our bias variance trade-off, it doesn't really fall right in the middle, quite like in that sweet spot, quite like cross-validation would. So it turns out we can use cross-validation in the Tidymodels framework using something called vfold_CV. This is going to be the function that we use for cross-validation. And so I'm going to create this cross-validation object using vfold_CV. And the first argument I specify is the data frame that I'd like to do my cross-validation on. And the second argument is the number of folds that I would like. So one thing I'll point out is in your book and in my notes, I use k-fold cross-validation. And here they use the letter V, so v-fold cross-validation. These are the same thing, it's just swapping out the k for the v. So this here is going to do 5-fold cross-validation. And if I look at this auto_CV function or object, I get this nice data frame where it says at the top that I'm doing 5-fold cross-validation. And I end up with 5 splits for each of my 5 folds. My first split contains 79 of 313 in my training data, 79 in my testing data. My second split has 313 in my training data, 79 in my testing data. Because 392 is not exactly divisible by 5, I end up with slightly different numbers in my third, fourth, and fifth split. I end up with 314 in my training data and 78 in my testing data. So now, to use this cross-validation data, instead of using the fit function or the last_fit function, I'm going to use something called fit_resamples. And so this is going to look really similar to the fit function that we've been fitting so far. We still specify the linear model specification as my first argument. My second argument is my formula, miles per gallon and horsepower. But now instead of specifying the data, I'm going to specify the resamples. And the resamples here is going to be this auto_CV object that I just created to do 5-fold cross-validation. And so if I run this, I end up with this object here, which states that I did five-fold cross-validation. It tells me what my splits were. So it tells me each of my 5 splits. It has an ID, fold 1 to fold 5. And then it has metrics here. And so each of these is going to be a data frame with the metrics associated with each of those splits. And those metrics are going to be the test error for, or the metrics calculated using the test data. So the 79 in the first 2 and the 78 in the last 3. So how do we actually get these metrics out? So this object looks kind of funny. We've basically got a data frame, but each of these objects in a data frame are a little bit tricky to extract. And so to be able to summarize over all of these metrics, we can use the collect underscore metrics function again. So here this is the same code that I showed before. I'm doing my fit resamples. LM spec is my linear model specification. I'm fitting this model. Y is miles per gallon. X is horsepower. My resamples is my auto underscore CV. That's my five-fold cross-validation object. And I'm going to save this as an object called results. Then I can take that results object and I can pipe it into the collect metrics function. And I end up with this nice data frame with 2 rows, RMSE and R squared. These are my 2 metrics. And then I've got 2 average values for these. So my average, my mean RMSE or root mean squared error is 4.93. It tells me my N, so how many that's averaged over. In this case, because I was doing five-fold cross-validation, it was averaged over 5 folds. And it also tells me my standard error, which is helpful to just understand kind of the variability of this estimate. Okay, so now in the final part of your application exercise, I want you to edit this code to get the five-fold cross-validation error rate for the following models. So you'll notice this model looks slightly different than my previous model. I've got horsepower and horsepower squared in this model. So I want you to try to edit this code below to get the five-fold cross-validation error rate for a model that's predicting miles per gallon from horsepower plus horsepower squared. All right, so make sure that you've knit your RMD file and go ahead and upload that final.html file of all of your application exercises across the lectures for today.